Hello friends, welcome to this video about the basic binary multiplication. Up to now, in the previous videos, we have seen binary addition and subtraction, and now it is the turn to binary multiplication. So, the objective of this video is to explain how to multiply binary numbers. This video is a basic approach to the binary multiplication, and for the sake of simplicity, all the binary numbers are unsigned. This is the first video of a set of videos dedicated to how to design binary multiplication circuits. First, let's see the binary multiplication table. There are only 4 possibilities. 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, 1 times 1 is 1. And this is an example of multiplication of two 4-bit binary numbers using the same method as the traditional paper and pencil. This is the multiplicand, this is the multiplier, and this is the product. 1010 is 10 in decimal, 1101 is 13 in decimal. We are multiplying 10 times 13, so the result should be 130. Let's do it. 1 times 0 is 0, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1, 0 times 0 is 0, 0 times 1 is 0, 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, 1 times 1 is 1, and so on. And now, doing the vertical addition, this is the binary number result. So let's verify if the result is correct. 1 2 to the power 7, 1 2 to the power 1 is equal to 130, so the result is correct. This is the generic representation of the multiplication process, where you can see how every bit of the multiplier is multiplied to every bit of the multiplicand. As I said, the process follows the same method as the traditional paper and pencil for decimal numbers. That is why this method is also known as the basic binary multiplication. These are the partial products. Observe how every new row of partial products is shifted one place according to the position of the multiplier digit. Note that from the point of view of hardware, to generate each partial product, you need just an AND gate. This is an AND gate. A and B are the inputs, and A times B is the output. Remember that in binary, the AND gate behavior is analogous to multiplication in arithmetic, because only outputs are 1 if both inputs are 1. Coming back to the previous multiplication, we can realize that the logic of the binary multiplication is very easy to perform. When the digit of the multiplier is 1, the partial products repeats the multiplicand. And when the digit is 0, the partial product is all zeros. So, the logic of partial products in binary is more simpler than in decimal multiplication. Also, as this example shows, when you multiply two 4-bit numbers, the number of bits of your result may become double, 8 bits in this case. That means when multiplying two n-digit numbers, the result may need 2 times n bits. This slide explains the binary multiplication of fractional numbers. That means the binary numbers with binary points. The process to perform the multiplication of binary numbers with binary points is the same as the multiplication with decimal points. Once we get to the final result, then the binary point is placed according to the total quantity of fractional digits in each number of the multiplicand and multiplier. So this is the way we can multiply two fractional binary numbers. For example, here the multiplicand has 3 binary points, the multiplier has 2 binary points, so the product has 5 binary points. Let's now introduce some important considerations about the circuit hardware for multiplication. Although binary multiplication in general is quite straightforward, the binary multiplication circuits require substantially more hardware than binary addition circuits. When multiplying two n-bit numbers, there are n-squared partial products generated. So, for example, for multiplying 4-bit numbers, 16 partial products are generated. For multiplying 8-bit numbers, 64 partial products are generated, and so on. Remember that to generate every partial product, you need an AND gate. So you will be needing a complex adder circuit to add so many partial products together. That's why you need a lot of hardware. So, since the beginning, the challenge for the engineers has been to find a simpler circuit hardware implementation for the multiplication. In our next presentations, we will explore the new ideas to solve this challenge. In summary, multiplying two binary numbers following the same methodology that we do with paper and pencil is fast and easy, but when the number of bits increase, the situation gets more complex, because multiplication requires substantially more hardware than addition due to the fact that the partial products increase by n squared. Also, in a system of n bits, the number of bits you may require to represent the product results is 2 times n. That's all for today. Thank you very much for your attention. Have a nice day. If you like this video, please hit the like button and subscribe for more videos. In the next video, we will explain how to multiply signed binary numbers.